Good day, everyone. This is Professor Friday coming at you one more time. Today we are going to be making the jump from the two-dimensional coordinate system to the three-dimensional coordinate system. So with that in mind, just wanted to review some terms that we know from the two-dimensional coordinate system. Take a real number line and a real number line and put them perpendicular to each other, and now you have a two-dimensional coordinate system. You have a horizontal axis, typically referred to as an x-axis. You have a vertical axis, typically referred to as a y-axis. You have four different regions in the plane that are split up by these two axes. They are referred to as quadrants. And in the four quadrants, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Whether x is positive or negative and whether y is positive or negative will put you into one of these four different quadrants. We represent points within the two-dimensional coordinate system as an x and a y, where x is referring to a horizontal distance and y is referring to a vertical distance. So this would be x and this would be y. Put it all together and you get what's known as the rectangular coordinate system, because x is coupled with y's and the coordinate axis forms a rectangle in its shape. Now typically all of the really good stuff happens in the first quadrant. So in quadrant 1, this is where x is greater than 0 and where y is greater than 0, or positive, if you will. Now because of that, imagine that this is an actual plane in which you could stand. Imagine that you're standing over here in quadrant 1 and you're looking toward the origin. Then what you would probably see in front of you is something like this. There would be an x-axis to your left, there would be a y-axis to your right, and now imagine that there is a third axis that comes from the origin going directly upward toward you. Now that would probably look like the following. That is going to be the z-axis. That is how we make the jump from 2 dimensions into 3 dimensions. This is now the three-dimensional coordinate system. There are certain terms that stay the same. There are certain terms that are going to change. You still have an x-axis, you still have a y-axis, you now have a z-axis. All three of the axes are supposed to be mutually perpendicular to each other. Imagine looking into the corner of a room and seeing a side wall on one side and a side wall on the other side and a floor. So despite the fact that they are all mutually perpendicular to each other, this is how we can kind of force some perspective into our three-dimensional coordinate system. So you still have axes. You have an x-axis, you have a y-axis, and you have a z-axis. Additionally, you have three different coordinate planes, and the three different coordinate planes are going to be defined by two of the axes. For example, the plane that's defined by the x-axis and the y-axis is going to be referred to as the xy plane. These are coordinate planes. You have the xy plane. The wall that's constructed from the x-axis and the z-axis, this wall over here, would be your xz coordinate plane. And the coordinate plane that gets constructed from the z-axis and the y-axis, the other side wall, if you will, is known as the yz plane. Now, each of these planes can be thought of as one of your three coordinates is going to be equal to 0. So for the xy plane, this is where your z-coordinate would be equal to 0. In the xz plane, this is where your y-coordinate is equal to 0. And in the yz plane, this would be where x is equal to 0. Additionally, these axes do technically extend to their negative sides as well. Now, given that we used to have 4 quadrants, we now have 8 different regions. The 4 different regions that are above the xy plane, and now 4 regions that are below the xy plane. Because there are 8 of them, we refer to them as octants. The majority of the good stuff that happens in the three-dimensional coordinate system happens in the first octant. In the first octant, this is where x is greater than 0, where y is greater than 0, and where z is greater than 0. Greater than, not equal to. So in the next video, we'll talk about how to actually create some points within this three-dimensional coordinate system.